Hi guys, today we're going to talk about simplifying square and cubed roots. And the I can statement we're working on is, I can recognize that the square root of 2 is irrational. And really we're looking at the square roots of any number that might be irrational. So let's list some perfect squares to begin with. We talked about these in class and you got this list, but here are our perfect squares up to 25. So 1 squared, here's 1 squared, 2 squared, and so on, all the way up to 25. So what happens if a number is not a perfect square? And we know now that that means that that number is irrational, but we can simplify that number as well. And you already know the process, kind of already know the process. The first part, it's to make a factor tree. So we're going to list the prime factors, or find the prime factorization of 96. And so 3 can go into 96 32 times. 4 times 8 is 32. 4 can be broken down into 2 times 2. 8 can be broken down into 2 times 4. And 4 can be broken down into 2 times 2. So now what I have is the square root of this big, long prime factorization. So there are 1, 2, 3, 4, 5 2's. So 1, 2, 3, 4, 5. 5 2's. And then a 3. And they're all being multiplied by each other. Now, we know that a number is a perfect square if I can have another number times itself equal that number. So when I'm simplifying a number that's not a perfect square, I'm still going to look for the perfect square factors in there. So you can think of this as when you were young and you wanted to go outside and you weren't allowed to go outside unless you had someone with you. Same idea for when we are simplifying square roots. So what you would do is you would find all the buddies, and they can go out as one group. So I have 2 groups of 2 that can come out, and I'm going to multiply those. And inside, I still have 2 times 3. Well, if I need to continue to simplify this, 2 times 2 is 4, and 2 times 3 is 6. And there you go. You have simplified the square root of 96. Let's look at another one. Let's look at 216. Okay? So I know 216, that 3 can go into it. 72 times. 72 is 8 times 9. And you know, if you remember, there are many ways that we can go ahead and simplify. Whatever factors you choose to do first, you're always going to get the same prime factorization if you have done it correctly. Okay? So once I find do my factor tree, I list my prime factorization inside the radical sign. I have 3 2's and 3 3's. And it's a big multiplication problem. And again, I'm going to take out the buddies or the pairs. Those can come out. And lonely 2 and 3 have to stay inside because they don't have buddies. And now I just go ahead and do the multiplication. 2 times 3 is 6, times the square root of 6. And I have simplified the square root of 216. So now it's your turn. Simplify the following square roots in the work section of your WSQ. But when you're done, hit play again. Okay. So we've talked about simplifying square roots. Now let's talk about simplifying cubed roots. And we'll start by reminding ourselves of the perfect cubes that we looked at in class. And again, this is 1 to the 3rd power, 2 to the 3rd power, 3 to the 3rd power, and so on. So these are the perfect cubes up to 25. And memorizing these is going to be a little less important. You don't have to memorize your perfect squares, but memorizing these is going to be you're not going to use that as often as the perfect squares. But let's talk about what happens if a number is not a perfect cube. Okay? And we're going to treat this very similar to how we simplify square roots. So, a cubed root means a number to the third power. We're going to take a number that when multiplied by itself 3 times instead of twice, then it can come out. So 54 is not a perfect cube. But I know 54, I'm going to do the prime factorization again. And 3 goes into 54 28 times. Oh, sorry, not 28 times. 18 times. And 1 times 8, or 18 is 2 times 9. And 9 is 3 times 3. So once I've got my prime factorization of 54, I can go ahead and write out my prime factorization inside the radical symbol, the cubed root, but I'm looking for the cubed root of it. So I have a 2 and 3 3s. And this time, the group gets a little bigger. In order to go outside, you have to have 3 buddies because it is the cubed root. So once I've got a buddy of 3, they can come out. Lonely 2 has to stay inside, and I have simplified the cubed root of 54. Let's look at another one. 375, cubed root. Well, I know 3 can go into it because I'm doing the prime factorization. Okay. And it's really important to know how to do this. It seems kind of silly that we're doing this and what's the point of this, and I know that's going to be some of your questions, so I'm going to go ahead and answer that right now. We simplify cubed roots because when we are working with them in algebraic expressions and algebraic equations, which you'll get into next year, just like when I'm trying to simplify with exponents, I have to have the same exponent. When I'm and I have to have like terms with the same variable. Same thing applies for working with cubed or square roots. You still need to have the same number in the radical, and that would be to make them common like terms. Okay, so I'm sorry. I've found that there are 3 5s in this prime factorization, so they can come out as a group of 5, and the 3 stays inside because he doesn't have a group of 3. So 5 times the cubed root of 3 is how we would simplify, is the simplified form of the cubed root of 375. So now it's your turn. Simplify the following cubed roots. Okay? Do this in the work section of your WSQ, and we are done with this lesson. So when you're done doing the work, go ahead and make sure you've got your summary and a good, thoughtful question.